Okay, the other thing that's really cool is we can prove the same thing by doing something slightly different and come up with a really cool expression. So I have to go back to the other definition of Kepler's law. What was that one again? The law of equal areas. So I am going to define a new term that you may or may not have heard of before. It is called, how would you say that?
Area velocity.
That's what it is. So far, we have been talking about velocities in a straight line, velocities of a particle moving in a circle. Now we're talking about the velocities of whole areas. So as areas move forward, the velocity of the area is called the areal velocity. Got it? Okay, now let's talk about what the formal definition of it is. Areal velocity is the rate at which the area is swept out by a particle as it moves along a curve. So think about it this way. As a particle moves along a curve, any curve, say from point A to point B, this area divided by the time it takes to cover this area is called the areal velocity. So areal velocity will be defined by dA over dt. Don't like this color. Yes.
So it would be from point A to point B, not the yellow part.
The particle is moving from point A to B, but the areal velocity is the velocity of this area as it moves from point A to
like
point B.
it's moving like this.
Yes. The whole area is being swept.
So you're saying it's not like a ray, but it's like a ray.
It's like a windshield wiper moving.
Okay.
Got it? So a windshield wiper doesn't do one point, right? It does a whole sweep every single time. And remember, as the planet moves, R changes, right? R is no longer constant. So keep that in mind as we do the rest of the derivation. So Kepler's law says this about the areal velocity. Areal velocity of a planet is a constant if we take the sun to be at the origin. And because of Kepler's laws, we know another thing, which is the areal velocity must be somehow related to angular momentum. I just made a bold statement. So now let's prove it. So in order to prove this, let me tell you two things. I want to tell you that the areal velocity depends on, number one, the central nature of the gravitational force. What does that mean? The central nature of gravitational force. F is a function of R only. And number two, it is useful for us to know that it does not depend on how the strength of the force varies with the radial distance of the sun. It remains constant. Okay? It itself changes to account for the fact. So instead of changing the gravitational force as the area is swept, we just change the area that we consider. Got it? We say it does not depend on how the strength of F varies with radial distance from the sun. These are very important to remember.